Welcome back, geometry students, as we continue to dive into Chapter 5, Congruency, where today in our video is going to be looking at Section 2, corresponding parts of congruent figures. So Section 1 was all about figuring out if two figures are congruent because they went under some isometry. Today we're going to look at what does that mean. Can we identify corresponding sides and angles of those congruent figures? Can we make and justify conclusions about congruent figures? So just to quickly recap, what we did in Section 1 was we tried to describe the isometry that would map one of these shapes on top of the other. All right, so if I tried to take and turn this one a little bit, and so what I'm going to do is try and take a quick screenshot and copy and paste a new version of that on here so that we can rotate it a little bit. So if I rotate that purple one, notice that it doesn't quite exactly map up. So not only does it need to rotate, but it also needs to reflect. Okay, so that's the answer here to part A. Rotate and reflect. It's the only way we can get it to map on top of each other. Now you could say, well, I'm going to reflect it first and then I'm going to rotate it, and that's fine as well. But really that's what we're doing here. Okay, so if we do that, I don't know if this is going to let me. Oh, sure. Nope, it's not going to let me. If we do that, what we have to try and remember is that S is going to be up here. And maybe if I rotate it just a little bit more. There we go. Now we can kind of see it better. We can see that if I reflect back this purple one on top, where those all match up. And so we've got to write this congruency statement. Okay, so let's just start with quadrilateral, N-I-C-E. Nice. It's a good pun. Hope you were laughing. Nice. So that quadrilateral is congruent to which one? Well, N matches up with M. The I here matches up with A. The C matches up with P, and the E with S. So quadrilateral nice is congruent to quadrilateral maps, M-A-P-S. And again, we can do that because we know that we rotated and reflected. Therefore, it's the exact same shape and size. List the 4 pairs of corresponding parts. All right, so really we're talking about the sides. The segment NI corresponds to segment MA. The side NE, or that segment NE, corresponds to segment MS. Or that angle E corresponds to angle S. They're in the same spot. They're in the same location. Angle C corresponds to angle P. And I could write down the others. There's 2 more for each of these. We're just going to keep plugging right along. What we do want to know, though, is are these figures directly congruent or are they oppositely congruent? The answer here would be oppositely congruent, because we had a reflection involved. Anytime there's a reflection, remember that the reflection is when the orientation changes between the 2 shapes. Therefore, they are oppositely congruent. So that's what we were looking at in Section 1, which directly leads to what we're going to be doing next. Now, these are some new properties that we haven't talked a lot about yet, but they are very important. So this would be a good time to pause. Make sure you write these down. Okay, these are all properties that we can use in our proofs. One of those properties is the reflexive property, just like a reflection, reflexive. I can say that this shape F is congruent to itself, right? It's the same shape, it's congruent. The symmetric property allows me to say that if I know F is congruent to G, then I can also say that G is congruent to F. And last but not least, this is probably one of the larger ones that we will use, is called the transitive property, which tells me if I know that F is congruent to G, and I also know that G is congruent to H, I can skip and just say F is also congruent to H, right? It takes these three parts and ties them together into one. So make sure you know those properties. Now, from there, we get into what's called the segment congruence theorem. And this segment congruence theorem states that two segments are congruent if and only if they have the same length. If and only if they have the same length. So basically what that allows me to do is if one segment is congruent to another segment over here, then we can say that their distances are equal. And that's kind of what we're doing in this picture. In the figure below, MA is congruent to TH. If MT is 25 miles, find AH, right? So MA is the same as TH. And if we quickly look at what a proof of this might look like, just to kind of walk through and getting used to these, setting up these proofs, we always start with the given, right? MA, the segment MA, is congruent to the segment TH. Then I'm going to put a comma, because there's another part, comma, MT without the segment. So now we're talking about the distance of MT is 25. All right, so we started with the segments, MA and TH. If they're congruent, this theorem up here says that they're the same distance. So MA, or the distance of MA, equals the distance of TH. What allows me to say that? It's that same theorem right up here, congruent statement theorem. It allows me to go back and forth between segments being congruent or equal. Now, if we look up here, I know that MA plus AT equals, right, MA plus TA, I'm sorry, AT equals TH, right? I can substitute MA plus TH. I'm adding the same thing to each side. Well, MA plus AT is really MT up in that diagram. TH, so that segment TH plus AT is really AH. That's the addition, segment addition property. Segment addition. Two small segments make up a larger segment. All right, and it's kind of looking at these. We're going to do a lot of these together in our live sessions. AH, if I know MT is 25 miles, and I know MT is AH, I can then say that it's 25, and this is ironically that transitive property. Now, we're going to work through a lot of similar ones like this together in our live sessions because it's really important to understand the scope and the sequence in which these are going, okay? But that's the segment congruence. The basic idea here is that I can go back and forth between segments being congruent and segments then being equal, their distance. The same thing is true for an angle congruence theorem. If I know that angle, I don't know, I'm just going to use two different examples here. Angle A is congruent to angle B. If I know that's true, then I can say the measure of angle A, whatever we get for the measurement, is equal to the measure of angle B. All right, that's the congruence theorem for angles. Angle congruence theorem allows us to go from congruence to their measures being equal. I really, though, want to focus on this one today. And we kind of introduced it in the last video. Excuse me. This is the most important one in the entire chapter. It's the one that we use to almost every proof. Corresponding parts in congruent figures theorem, CPCF. Corresponding parts, congruent figures. If I know that two figures are congruent, I know one triangle is congruent to another triangle, then any pair of corresponding parts are congruent. If I know that the figures, if I know the triangles are congruent, then I know their parts are congruent. CPCF. So they're telling us here, anytime you see given, they're telling us something. We have to assume triangle BIG is congruent to triangle CAT. Okay, well that means that B and C are corresponding. They're in the same spot. I and A are corresponding because they're in the same spot, or G and T are corresponding because they're in the same spot. And so those are the corresponding. Now, here's a possibility of what it might look like. Okay, B, I, and G. If I try to draw, and it's going to be a little hard because I'm using a different program, Jamboard makes it a little bit different. We have to line them up according to their order, all right? B has to be in the same spot as C, I has to be in the same spot as A, and T has to be in the same spot as G. Now, how do I show which ones are congruent? We use these marks. BG is the same as CT. I'm going to use 2 marks for IG to show that TA or CA has to be, and I'm using 3 marks to show that they're all different sizes potentially, there. Or B, that inside measure is the same as this measure. Or G, we'll use 2 of them now, is the same as this one. Or we'll use 3 for A. So these are called congruency marks, and they show which angles and which sides are congruent, which ones are corresponding if I have 2 figures that are indeed exactly the same. All right, so you should be able to, in your packet, answer question 9. List all pairs of congruent parts. If PQRS is a reflection, right? This is a reflection, meaning they are congruent. The 2 arrow tips, if you want to call them that, right? So Q and B, angle Q is congruent to angle B. That might be one of them. Angle C and R, A and P, and so on. Or that I can say this side over here is congruent to that side over here. Okay? So we're kind of flying through this a little bit quick because we introduced it last week. But these corresponding parts of congruent figures, CPCF, is a very essential theorem for us to move forward with our proofs. So make sure that you look at those. You're going to have some practice problems out of the textbook today. And if you have any questions, please make sure that you reach out. Until next time, everyone, stay safe.